We are going to start now chapter 8 of class 11th mathematics, binomial theorem, and this is lecture 1. Now the first thing we have over here, it is the definition of the binomial. So we are saying any expression of the form a plus b raised to the power n is called a binomial expression. Binomial means there are two terms a and b over here, and this sign we have either it may be plus sign or it may be multiplication sign. So this kind of expression, it is called binomial. This thing we have also studied when we have studied the chapter of polynomials, where we have studied monomial, binomial, trinomial in this way. So we are saying any expression of this form, it is called binomial expression. And if we expand this term, if we expand this expression, it is power n over here. If we expand this, we will obtain some terms over here, and the coefficients corresponding to those terms. Suppose I am talking about a plus b square. We have a square plus 2ab plus b square. So the coefficients we have over here, it is corresponding to this a square, it is 1, corresponding to ab it is 2, and corresponding to b square it is 1. So these coefficients we are talking about. These coefficients we can obtain by using the Pascal's triangle, which was introduced by Pascal in 1660. So in this chapter we are basically concerned with the expansion of these kind of expressions, that is a plus b raised to the power n. So if we talk about the binomial theorem, this is the statement of binomial theorem given for any non-negative integer. The proof we will study in our next slides. We are saying for only non-negative integer n, we can write a plus b raised to the power n. We are talking about the expression a plus b raised to the power n, that is equal to nc0 a raised to the power n plus nc1 a raised to the power n minus 1 into b. So basically the term b raised to the power 0 is over there. We have added power 1 to the b, and we have subtracted the power 1 power from a, and this term it is nc0. Out of n we have chosen 0 things, and second term we have it is nc1, and likewise we will continue, and last term will be ncn a raised to the power 0 b raised to the power n. A raised to the power 0 will be equal to 1. So this is the statement of the binomial theorem, that if we have to expand a plus b raised to the power n, we have the expansion in this form. We have the expansion in this form. So some examples are also given over here. First we are saying a plus b raised to the power 0, that is equal to 1. Next is a plus b raised to the power 1, that is a plus b, so it is 1c0 a plus 1c1 b, both these values, these are equal to 1. The next one, it is a plus b whole square. This thing we have seen that it is a square plus 2ab plus b square, so it is 2c0, 2c1 and 2c2. Next we have is a plus b whole cube. So if we open this term, it is a cube plus 3a square b plus 3ab square plus b cube. So this term we are saying 1 is there, we can write it is 3c0. Next it is 3, it is 3c1. Then it is again 3, it is 3c2, and this term it is 3c3. So these coefficients we are saying, these are called the binomial coefficients, and they are given by the Pascal triangle. Pascal triangle we have explained over here. We are saying when the index is 0, the coefficient we have it is 1. So coefficient we have it is 1 means we are talking about, if we have index is 0, it means I am talking about the expansion a plus b raised to the power 0. The answer we have it is 1. Now in this second case, we are saying when the index is 1, the coefficients we have it is 1 and 1. So the expansion we will obtain it is a plus b raised to the power 1, that is equal to a plus b. Both these coefficients, these are 1. Now the next case we have is when the index is 2, we are talking about 1, 2, 1. So we have the terms over here. When we expand this term, we have a plus b whole square. We have it is a square plus 2ab plus b square. We are talking about this value, it is 1 over here, then this time it is 2 over here, and again this is 1 over here. So these three coefficients, these are given over here. And how we are getting these coefficients? We are saying it is corresponding to this one, we obtain it is 1, corresponding to this one, it is 1. We are adding both these values. 1 plus 1, it is 2. The next coefficient is obtained. We are saying corresponding to this one, we have 1. Then 1 plus 2 will give us 3. 1 plus 2 will give us 3. Then we have this time it is 1. Similarly, the next coefficients, it is 1. Then 1 plus 3 is 4. Then 3 plus 3 is 6. Then 3 plus 1 is 4. And last term again it is 1. Next is 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And these two terms we have it is 1. So suppose I am talking about the expansion corresponding to say 7. I am talking about the expansion corresponding to the index 7. It means I am talking about the expansion a plus b raised to the power 7. So the coefficients we have it is 1, 7, 21, 35, 35, 21, 7 and 1. And terms we will have over here, it is first term will be a raised to the power 7 plus a raised to the power 6 into b plus a raised to the power 5 into b square plus a raised to the power 4 into a cube b cube plus a raised to the power 3 into b4 plus a raised to the power 2 into a 5 plus a raised to the power 1 into b raised to the power 6, and last we have it is b raised to the power 7. So we are saying what is expansion of a plus b raised to the power 7? It is given by this expression, where these coefficients we are saying, these coefficients, these are the basically the elements of the Pascal triangle, that is obtained by adding this is 1 plus 6 7, then 6 plus 15 21, 15 plus 20 35. Or we can see that these coefficients, these are basically 7c0, 7c1, 7c2, 7c3, 7c4, 7c5, 7c6 and 7c7. So these are the coefficients we are saying that we are obtaining from the Pascal triangle. These are just the values of these binomial coefficients. Next is binomial theorem for positive integral index. So we are saying if a and b are real numbers and n belongs to n. Now we are not talking about the non-negative numbers. We are talking about n belongs to n. We have this is the expression for the binomial theorem and we have to prove this result. So to prove this result, we are saying we assume we prove this first of all for n is equal to 1. If we substitute n is equal to 1, we will get a plus b raised to the power 1, that is equal to 1c0 a plus 1c1b, that is equal to a plus b. So we are saying that p of 1 is true. Next, suppose we assume that it is true for m, that is we are saying that p of m be true. Then we have this expression, we are saying this is true. This expression we are saying this is true. This thing we have assumed. We are using the principle of mathematical induction. We have assumed that it is true for p m. So if we multiply the both sides, we have to prove that p of m plus 1 is also true. So what we are going to do, we are going to multiply both sides of this equation by a plus b. Now look at this right hand side over here. When we multiply these terms, we are saying this side, this left hand side, it will a plus b raised to the power m plus 1, and the right hand side it will become in this form. We have multiplied it with a plus b. We multiplied all these terms with a plus b. What we have obtained over here, it is mc0 plus mc1. Next it is mc1 plus mc2 with this coefficient. Next it is mcm minus 1 into mcm, and last it is mcm. And we know that the value of mc0 plus mc1, that is equal to m plus 1 c1. We are talking about the sum of these two values, it is mcm plus 1. Why? Because we are using this result that mcr minus 1 plus mcr, that is equal to m plus 1cr. We are using this result. Now for this first term mc0, we can also write this is mc0, that is equal to 1, that is equal to m plus 1c0. And for this last term we are writing it is mcm. We can write mcm is equal to 1 is equal to m plus 1cm plus 1. So we are saying we will obtain the expression in this form. We will obtain the expression in this form. And this thing proves that we are having a plus b raised to power m plus 1. We have the coefficients m plus 1 c0, m plus 1 c1, m plus 1 c2, so on up to m plus 1 cm plus 1. So we are saying that p of m plus 1 is true whenever p of m is true. So we obtain that this binomial theorem, it holds for all n belongs to, so it is true for all n belongs to n, for all natural numbers. So over here we have expressed or written the binomial theorem in the compact form. We can write it in this form. We are saying a plus b raised to the power n, that is equal to, this is the notation for sum. Sum is taking from r is equal to 0 to n. So we are saying the value of r will vary over here. The first term we are saying it is nc, r is varying from 0, a raised to the power n minus 0, b raised to the power 0, plus nc1, a raised to the power n minus 1, b raised to the power 1, so on up to plus nc, last term corresponding to the r we have, the upper limit we have over here, it is n. So it is ncn, a raised to the power n minus n, b raised to the power n. So this is the binomial theorem that we have already seen. Next is some observations in the binomial expression. So first one is that the expansion of a plus b raised to the power n has n plus 1 terms. If we will look at the binomial expression, it has n plus 1 terms. Second is, we know that ncr is equal to ncn minus r. So what we obtain is that nc0, that will be equal to ncn, nc1 will be equal to ncn minus 1, and we are writing the binomial expansion. We are saying it is nc0, a raised to the power n, b raised to the power 0. Next we are writing it is nc1, n a raised to the power n minus 1b, plus so on up to the last term we have, it is ncn, a raised to the power 0, b raised to the power n. Second last term we have, it is ncn minus 1, a raised to the power 1, b raised to the power n minus 1. Look at these terms over here. We are saying nc0 is equal to ncn, nc0 is equal to ncn. We are saying nc1, that is equal to ncn minus 1. So what we are getting over here, what we can observe from this is that the terms equidistant from the coefficient of the terms equidistant from the beginning and the end in a binomial expansion, they are equal. That is, this nc0, that is equal to ncn, this nc1, that is equal to ncn minus 1. All these corresponding coefficients we have, they are equal. Next we are talking about the general term. So we are saying that the binomial expansion, when we are talking about a plus b raised to the power n, we can write that is equal to sigma r is equal to 0 to n, ncr, a raised to the power n minus r, b raised to the power r. So this term basically we are saying this is the r plus 1th term, and this term it is called the general term of the binomial expression, and we write this general term as tr plus 1. This is important to note that we are talking about the general term. It is r plus 1th term. It is not the rth term. It is r plus 1th term. But the powers we have over here, and we look at these values over here, it is ncr, a raised to the power n minus r, b raised to the power r. But this term we are saying it is the r plus 1 term. Next is, in the expansion of a plus b raised to the power n, there are n plus 1 terms. This thing we have already seen. So if we are talking about the middle term, we are having two cases. When n is even, means, suppose I am talking about the expansion of a plus b square. In this case n is even, we have a square plus 2ab plus b square. So middle term we have it is this 2. So we are saying the middle term it is given by n by 2 plus 1th term. We are saying it is n by 2 plus 1, that is equal to 2 by 2 plus 1, that is equal to the second term. Now next case we have when n is odd. Suppose we are talking about a plus b whole cube. So it is a cube plus 3a square b plus 3ab square plus b cube. So in this case we are saying the value of n is equal to 3. We have two middle terms. First thing, we have two middle terms. It is clear from here. We are saying these two terms, both these terms, these are the middle terms. So how we write the formula over here corresponding to these terms? We are saying 1 by 2 into n plus 1th term. The answer we have it is 1 by 2 into 3 plus 1, that is equal to 1 by 2 into 4, that is equal to the second term. And we are saying 1 by 2 into 3 plus 1, that is equal to this value we got 4 by 2, that is 2 plus 1, that is equal to the third term. So we are saying both the second and the third term, both these terms, these are the middle terms. So there are two middle terms in this case. Next is pth term from the end in a plus b raised to the power n. Again, suppose I am talking about a plus b raised to the power 4. I can write it is a raised to the power 4 plus 4a raised to the power 3b plus 6a square b square plus 4ab cube plus b raised to the power 4. Now suppose I am saying the second term, we are talking about the pth term from the end. I am talking about the second term, this is second term from end. We are saying the total number of terms we have in this case, it is total terms, that is equal to 5, that is we are saying it is n plus 1 terms. If I am saying the pth term from end, so if I have to see that which term it is from the beginning, so we are saying it is n plus 1 minus p plus 1th term from beginning, that is n minus p plus 2th term from beginning. So if we look at this term over here, it is 1, 2, 3 and 4th term from beginning. So we are saying it is value of n we have in this case, it is 4. We are saying the value of n we have it is 4 minus the value of p we are saying it is 2 plus 2. So the answer we are getting it is 4. So we are saying the second term from the end, it is the 4th term from the beginning. Next is the results on binomial coefficients. So the statement of the binomial theorem, it is being written over here. This is the statement of the binomial theorem. Now in this result, in this binomial theorem, first result we have is if we substitute a is equal to 1 and b is equal to 1, the answer we obtain it is 2 raised to the power n, that is equal to nc0 plus nc1 plus nc2 so on up to plus ncn minus 1 plus ncn. So this is our first result, that sum of all these binomial coefficients, it is equal to 2 raised to the power n. This kind of result we have also used in our chapter when we were counting the number of subsets. Next is if we put a is equal to 1 and b is equal to minus 1, the answer I will obtain over here, it is 1 minus 1 raised to the power n, that is equal to if I substitute a is equal to 1, I will get it is nc0, then it is minus nc1, then it is plus nc2, then it is minus nc3, so on up to we obtain some terms over here. It depends upon the value of n, whether it is even or odd. Correspondingly, we will obtain the last term. So if we are saying, looking at this term over here, this value is equal to 0. So what we obtain is that nc0 plus nc2 plus nc4 plus so on, this is equal to nc1 plus nc3 plus nc5, so on. And we know that the sum of all these values is 2 raised to the power n. So half values are on this side, half values are on this side, even are on this side, odd are on this side. So we get it is 2 raised to the power n by 2, that is equal to 2 raised to the power n minus 1. So we are saying that the sum of these values is equal to 2 raised to the power n minus 1. Next is, if we substitute a is equal to 1 and b is equal to x, we will obtain the expansion in this form, that a plus x raised to the power n is equal to this. Or in another way, we can write a plus x raised to the power n is equal to sigma r is equal to 0 to n ncr x raised to the power r. So this is the expansion we have obtained for 1 plus x raised to the power n. Next is, if we replace b by minus b, we will have the expansion in the form a minus b raised to the power n. So what will happen over here? We have replaced b with minus b. So in the expansion, what we will obtain? We will obtain a term minus 1 raised to the power r. And this r is basically, we are saying, the power of b. Whenever this value of r is even, we will have the positive term. And whenever the value of this r is odd, we will have the negative term. So we are saying, we are talking about a minus b raised to the power n. So it is basically nc0 a raised to the power n plus nc1 a raised to the power n minus 1 into minus b we have now. Next term we have it is nc2 a raised to the power n minus 2 minus b square. Minus b square means we will obtain b square, and likewise it will continue. The rth term we will have it is minus 1 raised to the power r ncr a raised to the power n minus r b raised to the power r, and the last term we will have it is minus 1 raised to the power n ncn b raised to the power n. Next is, if we put x is a is equal to 1 and b is equal to x in this expansion, or we are saying that in the binomial expansion we are substituting a is equal to 1 and x is equal to minus 1, we will obtain the expansion in this form. We are saying, if we have substituted a is equal to 1, all these a will become equal to 1, and we will obtain the expansion in this form. This is the general term we are having over here. It is tr is equal to r plus 1. The general term we are saying, it is minus 1 raised to the power r ncr x raised to the power r. This is the general term we obtain in this particular case. So based upon this, we have certain problems. First is, we have to expand this expression. So it is x square plus 2y raised to the power 5. One method to expand this is that we can use, remember the Pascal triangles up to some term, and we can directly write the value. Or another way we have it is 5c0 x square raised to the power 5. Next term will be 5c1 x square raised to the power 4 and 2y raised to the power 1. Next is 5c2 x square raised to the power 3 and 2y raised to the power 2. Next is plus 5c3 x square raised to the power 2 and 2y raised to the power 3. Next is plus 5c4 x square raised to the power 2y raised to the power 4. And last we have it is 5c5 2y raised to the power 5, and when we calculate the values of all these terms, we will obtain the coefficients in the form 5c0 it is 1, 5c1 it is 5, similarly 5c4 will be 5. When we are talking about the value of 5c2, the value of 5c2 we will have 10, similarly 5c3 will be equal to 10. So we are saying the value of 5c2 is 10, 5c3 is 10, this value is 5, this value is 5, this value is 1, this value is 1. So when we expand this term, when we solve these values, when we simplify these values, we will obtain the final answer in this form. Next is expand using the binomial expansion. We have to expand this term using the binomial expansion. So what we are going to do over here, it is x cube minus 2 by x square whole raised to the power 6. So we are saying it is power 6 over here, and we want to expand this. It is 6c0 x cube raised to the power 6. Next is plus 6c1 x cube raised to the power 5 into minus 2 by x square. Then it is plus 6c2 x cube raised to the power 4 minus 2 by x square raised to the power 2. Then it is plus 6c3 x square raised to the power 3 minus 2 by x square raised to the power 3. Next is plus 6c4 x square raised to the power 2 into minus 2 by x square raised to the power 4. Next is plus 6c5 x square raised to the power 1 minus 2 by x square raised to the power 5. And last we have it is plus 6c6 x square raised to the power 0 and minus 2 by x square raised to the power 6. Now when we simplify these terms, we will obtain the answer. This is x raised to the power 18. Next it is x raised to the power 15 by x square, we are left with x13. This is x raised to the power 12 by x raised to the power 4, it is x raised to the power 8. Next is x cube, it is x square, x7 and x12. And we obtain the final answer in this form. When you will simplify these values, and you will substitute the values of this 6c0, that is equal to 1, this 6c1, that is equal to 6. Similarly, this is equal to the value 6c6, this is equal to the value 6c5, 6c2 and 6c4 will be equal, and we will have the value of 6c3. You substitute all these values and you will obtain the final answer in this form. Next is expand 1 plus x square whole cube using the binomial expansion. So there are three terms over here. First thing, this is a trinomial. This is not a binomial, but we have to use the binomial expansion. So we convert it to binomial form and we write 1 plus x is equal to y. So this problem, it will be transformed to the form y plus x square whole cube. Now when we open this term using the binomial expansion, we will have it as y cube, it is 3c0 is 1 plus 3 times y square into x square plus 3 times, this is 3c1, this is 3c2. Now we have it as y into x square whole raised to the power 2, and last term we have it as x square whole raised to the power 3. Now if we substitute the value of y over here, we are substituting the value of y over here, we are having it is the first term, then it is 3x square, then 3x raised to the power 4 plus x raised to the power 6, and the terms that we have over here, it is y cube we are saying. So value of y we have it is 1 plus x. Next we have it is y square, it is 1 plus x. Next we have it is 1 plus x, and it is x raised to the power 6. So again, by applying the binomial theorem on this, we will get it is 1 plus 3x square plus 3x plus x cube plus 3x square into 1 plus 2x plus x square plus 3x raised to the power 4 into 1 plus x raised to the power 6, and on simplifying, on correcting the like terms, we will obtain the final answer in this form, that it is x raised to the power 6 plus 3x raised to the power 5 plus 6x raised to the power 4 plus 7x cube plus 6x square plus 3x plus 1. So this is the final answer we obtain in this case. Now the next question we have is, we have to expand this expression. Again, this 1 minus x, if we substitute it equal to y, this question it will become y plus x square raised to the power 4, and for n is equal to 4, the binomial coefficients we have it is 1, 4, 6, 4 and 1. So the answer we obtain it is y raised to the power 4 plus 4 into y cube into x square. Next coefficient we have it is 6, and we will have over here it is y square and x raised to the power 4. Next we will have the coefficient, it is 4 and value of y, and then it is x raised to the power 6, and last term again coefficient it is 1, so it is x raised to the power 8. Now in place of this y, we are writing it is 1 minus x. In place of this y, we are writing it is 1 minus x cube. This is 1 minus x raised to the power 4, 1 minus x square, 1 minus x. Now 1 minus x raised to the power 4, it is again power 4 is there. So the expansion we will have over here it is 1 minus 4x plus 6x square minus 4x cube plus x raised to the power 4. Next 1 minus x whole cube, the expansion for this term we have 4x square is already over there, and expansion of this term it is 1 minus x plus x square minus x cube. The coefficients we have over here it is 3 and 3. Next we have is plus 6x raised to the power 4 is already there, and 1 plus minus x square, it is 1 minus 2x plus x square. Then next it is plus 4 into 1 minus x into x raised to the power 6, and last it is x raised to the power 8. Now by collecting the terms with the, if we collect the terms with the like powers of x, we will obtain the final answer in this form, that it is x raised to the power 8 minus 4x raised to the power 7 plus 10x raised to the power 6 minus 16x raised to the power 5 plus 19x raised to the power 4 minus 16x cube plus 10x square minus 4x plus 1. So by collecting the like terms with the like powers, we will obtain this final answer. Next is, we have to expand a plus b raised to the power 4 plus a minus b raised to the power 4, and we have to use it to evaluate this particular value. So if we are talking about a plus b raised to the power 4, the answer we will have it is a raised to the power 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b raised to the power 4. When it is minus sign over here, we are talking about this case, then it is a minus b raised to the power 4. The answers we will have it is a raised to the power 4 minus 4a cube b plus 6a square b square minus 4ab cube plus b raised to the power 4. Now when we add both these values, these terms will be cancelled, and the answer we will obtain it is 2 times a raised to the power 4 plus 6a square b square plus b raised to the power 4. Now the values we have to substitute over here. This is the value we have evaluated. This is the first part we have done. Now in the second part, in place of a, we have it is, in place of a we have it is x square, so we will get it is x raised to the power 8 plus 6 into x raised to the power 4 into 1 minus x square plus b raised to the power 4 is 1 minus x square whole square. So we will get it is 2 times x raised to the power 8 plus 6x raised to the power 4 minus 6x raised to the power, it is 6. Then it is plus 1 plus x raised to the power 4 minus 2x raised to the power 4. So if we write the final answer, it is 2 times x raised to the power 8 minus 6x raised to the power 6. Then when we are looking at the terms with power 4, it is 6x raised to the power 4, 7x raised to the power 4, and this will become 5x raised to the power 4. This term we will have it is not power 4, it is 2 over here. So we will get it is plus 7x raised to the power 4. And then we are left with is minus 2x square plus 1. And when we multiply these terms, we will obtain the final answer in this form, that it is 2x raised to the power 8 minus 12x raised to the power 6, then plus 14x raised to the power 4, then minus 4x raised to the power 2, and last term we have it is plus 2 over here. So this is the final answer we obtain for this second part. Next is find the 10th term in the expansion of this. It is 2x square plus 1 by x raised to the power 12. Now we know that the general term t r plus 1, that is r plus the 1th term we are talking about, it is given by the formula we have, the value of n we have, it is given by NCR, a raised to the power n minus r, b raised to the power r. Over here the value of n we have, it is 12, and we want to calculate the 10th term. It means we want to calculate T10, this thing we have to calculate. So the value of r we will have, it is 9, then r plus 1 will be 10. So we are saying that T10, that is equal to T of 9 plus 1, that is equal to 12C9 a raised to the power, we are saying n minus r, it is 3, b raised to the power r, it is 9. Now the value of a and b we have, it is, we are saying T10, that is equal to 12C9, a we have, it is 2x square raised to the power 3, and it is 1 by x raised to the power 9. This value we are saying it is 1 by x raised to the power 9. Now 12C9, it is 12 into 11 into 10 divided by 3 into 2 into 1 into 8x raised to the power 6 into 1 by x raised to the power 9. When we solve this value, we will get it is 1760 upon x cube. So this is the 10th term of this expansion. Next is find the 6th term in the expansion of this. So we have the value of n is 9. The value of r we will have, it is 5. Because we want to calculate T6, so it is T of 5 plus 1, that is equal to 9C5, 4x by 5 raised to the power 4, and minus 5 by 2x raised to the power 5. So we are getting the answer, it is minus 9C5 is 9 into 8 into 7 into 6 divided by 4 into 3 into 2 into 1. Then it is 4 raised to the power 4 x raised to the power 4 divided by 5 raised to the power 4. Then it is 5 raised to the power 5 divided by 2 raised to the power 5 into x raised to the power 5. Now if we look at these values over here, we can write this 4 raised to the power 4 is 4 raised to the power 8, 2 raised to the power 8. This 2 raised to the power 5 and 2 raised to the power 8 gets cancelled, we are left with 2 raised to the power 3. This 5 raised to the power 4 and 5 raised to the power 5 get cancelled, we are left with 5. This x raised to the power 4 and x raised to the power 5 is cancelled, we are left with x. And on multiplying these terms, this gets cancelled. this term gets cancelled, and the final answer we will obtain, this minus sign is already there, so it is minus 5040 by x. So this is the sixth term in this expansion. Next is find the fourth term from the end in the expansion of this value. So when we are saying that we have to calculate the fourth term from the end, so that will correspond to the value of n we have, it is 9, the value of p we have, that is 4. So we are saying it is 9 minus 4 plus 2th term from beginning. So this value we obtain, this is equal to, we are saying the 7th term from beginning. It means the value of r we will have, it is 6. It means we have to calculate the value of t7, that is equal to t6 plus 1, that is equal to 9c6 x cube by 2 whole raised to the power 3 and minus 2 by x square raised to the power 6. Now this power 6 is there, so this negative sign is of no use over there. When we take minus 1 raised to power 6, it is plus 1. So the answer we get, it is 9 into 8 into 7 divided by 3 into 2 into 1, x raised to the power 9 by 8 into 64 by x raised to the power 12. So the answer we obtain, it is 672 by x cube. So this is the final answer we obtain in this case. This is the fourth term from the end, or we are saying this is the seventh term from beginning. Now the next question we have is, if the ratio of the fifth term from the beginning to the fifth term from the end in the expansion of this is root 6 is to 1. So this expression we can write, this expression we are saying it is 2 raised to the power 1 by 4 plus 3 raised to the power minus 1 by 4 raised to the power n. And we are talking about the fifth term from the beginning, and we are talking about the fifth term from the end. Fifth term from the end means we are talking about the value n minus 5 plus 2, that is equal to t of n minus 3. We can write this is t of n minus 4 plus 1, and we are talking over here, it is t of 4 plus 1. These are the values we are talking over here. Now if the ratio of both these terms is given, now look at this expansion. The general term we have, tr we have, tr plus 1 we are talking about, it is ncr 2 raised to the power n minus r by 4 and 3 raised to the power minus r by 4. So if we use both these values over here, we are obtaining the value of r in first case, it is 4. So we will get, it is nc4, I am talking about t5, we will have the value over here, it is nc4 2 raised to the power n minus r, the value of r we have, it is 4 by 4, 3 raised to the power minus 4 by 4, and we are dividing this value with, it is again nc, in place of r now we have, it is n minus 4, then we have 2 raised to the power n minus 4 divided by 4 and 3 raised to the power minus of n minus 4 by 4. Both these values, these are equal. We know that nc4 and n minus 4, both these values, these are equal to each other, and this ratio is given to be equal to square root 6 by 1. So when we are writing it is equal to square root 6 by 1, we are getting that square root 6 is equal to, if we look at this value, it is n minus 4 plus 4, this power will become 1, this power is minus 1. So the answer we are getting it is 2 raised to the power n minus 4 by 4 minus 1 divided by, or we are saying it is multiplied by 3 raised to the power n minus 4 by 4 minus 1. So this is equal to 2 raised to the power. When we solve this value, it will become n minus 8 by 4 into 3 raised to the power n minus 8 by 4. So what obtained from this is that square root 6 is equal to 2 raised to the power n minus 8 by 4 into 3 raised to the power n minus 8 by 4. This is equal to 6 raised to the power n minus 8 by 4, and this is 6 raised to the power 1 by 2. Now if we compare both these powers, we will obtain that n minus 8 by 4 is equal to 1 by 2. This implies us 2n minus 16 is equal to 4. This implies us 2n is equal to 20. This implies us n is equal to 10. So this is the required value of n that we have in this question. Now in this next question, we have to find the term independent of x in the expansion of this value. So if we write the general term over here, we are talking about t of r plus 1, that is equal to, we have it is 15cr 3x square by 2 raised to the power 15 minus r and minus 1 by 3x raised to the power r. Now look at these terms over here. It is minus 1 raised to the power r, 15cr, then it is 3 by 2 raised to the power 15 minus r, then it is 1 by 3 raised to the power r. Now next we are left with is x square raised to the power 15 minus r divided by x raised to the power r. So we are saying this is equal to minus 1 raised to the power r, 15cr, 3 by 2 raised to the power 15 minus r into 1 by 3 raised to the power r, and this remaining term we will have it is x raised to the power 30 minus 2r minus r. Now we are being asked that the term, we have to find the term independent of x. Term independent of x means this power should be equal to, we are saying this power should be equal to 0. So we get that 30 minus 3r is equal to 0. So this implies us r is equal to 10. So we are saying that the term independent of x, that will be the case when r is equal to 10, and in that case this whole value that will be equal to 1. Now we have to calculate this coefficient. When r is equal to 10, we are getting it is minus 1 raised to the power 10. We are saying it is minus 1 raised to the power 10. 15c10, 3 by 2 raised to the power 5 and 1 by 3 raised to the power 10. So minus 1 raised to the power 10 will become 1, and this will become 15 into 14 into 13 into 12 into 11 divided by 5 into 4 into 3 into 2 into 1, then into the next value we will have over here, this 3 raised to the power 5, this will be get cancelled over here, and we are left with this 3 raised to the power 5. So we are getting over here it is 1 by 6 raised to the power 5. And when we solve this whole value, we are talking about this whole value we are having. When we solve this whole value, the final answer we obtain, it is 1001 divided by 2592. So it is 1001 divided by 2592. So this is the term independent of x in this expansion. Next is find the term independent of x in the expansion of this. So again, if we write the general term over here, it is tr plus 1, that is equal to 10 cr. Then it is square root x by square root 3 raised to the power 10 minus r. Then it is square root 3 by 2x square raised to the power r. Now if we try to simplify these values, we are having x raised to the power 10 minus r by 2 over 3 raised to the power 10 minus r by 2 into 3 raised to the power r by 2 by 2 raised to the power r, x raised to the power 2r. We are getting it is 10 cr. Then it is 3 raised to the power r by 2 by 3 raised to the power 10 minus r by 2 into 2 raised to the power r. Now the terms we are left over here, it is x raised to the power 10 minus r by 2 minus 2r, and the value of this power, this should be equal to 0 for the term independent to be of x. We are saying this is equal to 0. So we get 10 minus r by 2 is equal to 2r. So 10 minus r is equal to 4r. So the value of r we obtain, that is equal to 2. Now if we substitute r is equal to 2 in this term, the answer we obtain, it is 10 c2 3 raised to the power 1 divided by 3 raised to the power 4 into 2 raised to the power 2. Now 10 c2, it is 10 into 9 by 2 into 1 into 3 raised to the power minus 3 into 2 raised to the power minus 2. We are saying these terms get cancelled and we are left with is upon 3, and the answer we obtain, it is 5 over here. So it is 5 by 12. So we are saying the term independent of x in the given expansion, it is 5 by 12. Now next is, if the term free from x in the expansion of this value is 405, then we have to calculate the value of m. So the general term we have over here, it is 10 cr square root of x raised to the power 10 minus r and minus m by x square raised to the power r, and the value of this is given to be 405, with the condition that this term should be independent of x. So if we try to simplify this value, we get it is 10 cr x raised to the power 10 minus r by 2 minus 1 raised to the power r m raised to the power r over x raised to the power 2r. Now for this term to be equal to 1, we are saying the power should be equal to 0. So we are saying 10 minus r by 2 minus 2r is equal to 0. So this implies us 10 minus r is equal to 4r. So this implies us r is equal to 2. So we are saying if we substitute r is equal to 2 in this equation, it will be equal to 405. So we are getting r is equal to 2 means this value will become equal to 1 minus 1 raised to the power 2 10 c2 m raised to the power 2, that is equal to 405. This value will become 1, and 10 c2 will be 10 into 9 divided by 2. So we are getting it is 45 m square, that is equal to 405. We are getting the value of m square is 9. So this implies us that the value of m we can have, it is plus or minus 3. So these are the possible values of m that we can have in this case, when the value of the term free from x, that will be 405. 5. Next is find the coefficient of x raised to the power 32 and 1 by x raised to power 17 in the expansion of this term. So again, the general term for this expansion, it is 15CR. We are talking about the term TR plus 1. It is 15CR. X raised to the power 4 raised to the power 15 minus R and minus 1 by 3 raised to the power R. So we are writing this is equal to minus 1 raised to the power R, 15 CR, then we will have it is x raised to the power, this is 1 by x cube raised to the power R, and the power we will obtain over here, it is x raised to the power, we will have the value 15, 4 into 15 minus R, minus 3R. So the answer we will obtain in this case, it is 60 minus 7R. We are talking about this power, it is 60 minus 7R. Now when we have to find the coefficient of x raised to the power 32, it means the value of this term 60 minus 7R, that should be equal to 32. So we are, from this calculation we obtain that the value of 7R we have, it is equal to 28, and this implies us R is equal to 4. Now if we substitute R is equal to 4 in this equation, we will obtain the answer is 15C4. In the second case, we are saying when we have to find the coefficient of 1 by x raised to the power 17, we are saying that this value 60 minus 7R, that should be equal to minus 17. This implies us that 77 is equal to 7R, and this implies us R is equal to 11. It means the coefficient we obtain in this case, it is minus 1, 15C 11, that is equal to minus of 15C4, and the value of 15C4 we have, it is minus of 15 into 14 into 13 into 12 divided by 4 into 3 into 2 into 1, and the answer we will get, it is minus 1365, and the value of this term, this will be 1365. So these are the two values, these are the two required coefficients in this case. We are saying the coefficient of x raised to power 32 is 1365, and that the coefficient of x raised to power minus 17 is minus 1365. So these are the final answers we obtain in these cases.